Hi, welcome to WaHPACT. I am Ajay and I'll be your pactor for introduction to pair of linear equations in two variables. I know this topic is long, but don't worry. We'll be using the why effect, that is, what, why, when, where, who, and how to unravel the mystery behind all these words and establish a great understanding. This is a very interesting course that challenges the core idea of applying logic. This course not only nurtures our logical ability to solve real-life problems, but also shows both a graphical and an algebraic way to solve the same problem. In other words, we'll be giving shape to what we speak and also solve for practical solutions. The video can be used as a revision supplement to the NCERT book. Let's start with some facts. The assumption is that you're already aware about these facts and have a good fundamental understanding. Constant is a number having fixed value and cannot be changed. Variable is a quantity that may change within the context of the mathematical problem or experiment. Equations are mathematical statements that represent an equality represented by the equal sign. They have a LHS, that is left-hand side, and RHS, a right-hand side. Independent product of factors, that is constant and variables, form a term. For example, 3x. 3 as a constant and x as a variable form a term 3x. Another example would be 4x plus 2 has two terms. The first term is 4x, where 4 is a constant and x is a variable. And another term is 2, where we only have the constant 2 and we do not have the variable. Power of a variable. The exponent value of a variable is called the power of a variable. For example, x squared has the power 2 and 3x cubed has a power of 3. Degree of a term. The sum of the exponents of the variables. Example, x squared has degree 2, x squared y squared has degree 4, and x squared y cubed z cubed has a degree 8. The assumption here is that x, y, and z are all variables. Degree of an equation. The maximum degree of all the terms of an equation mark the degree of an equation. For example, x cubed plus xy cubed plus x cubed y squared is equal to 0 has a degree of 5. Quadratic equation. If the degree of an equation is 2, it is called quadratic equation. For example, 3x squared plus 2x plus 4 is equal to 0 is a quadratic equation. Let's start our journey of pair of linear equations in two variables. So, what is a linear equation? A linear equation are a combination of constants and variables. A linear equation can have one or many variables. The combined power of variables of each term cannot be greater than 1. That is, it has to be exactly equal to 1. Assuming x, y, and z are all variables, 3x plus 4 is equal to 0, 3x plus 4y plus 5 is equal to 0, and 3x plus 4y plus 5z plus 6 is equal to 0 are all linear equations in 1, 2, and 3 variables respectively. But 3x squared plus 4 is equal to 0, 3xy plus 4y plus 5 is equal to 0, or 3xy plus 4yz plus 5z is equal to 0 are not linear equations, as the power of each term is not less than 1. A linear equation in one variable is represented as ax plus b is equal to 0, where a is not equal to 0 and x is a variable. A linear equation in two or more variables is also possible. So the next logical question is, what is a linear equation in two variables? A linear equation in two variables is represented as ax plus by plus c is equal to 0, where a is not equal to 0 and or b is not equal to 0. That is, a and b are not both zeros at the same time. This is often described as a squared plus b squared is not equal to 0. Any equation of the form xy is equal to 3, where x and y are variables, is not a linear equation in two variables, as the power of the term is 2. And we know that for a linear equation, the power of each term has to be equal to or less than 1. A linear equation in two variables is described as a straight line. Example, 3x plus 4y is equal to 12. And we know that for a linear equation, the power of each term has to be equal to 1. Now that we have understood what is a linear equation in two variables, the next question is how linear equation in two variables can be described geometrically. The following diagram shows a straight line that describes a linear equation in two variables graphically. For example, 3x plus 4y is equal to 12. So the next logical question is, what describes a pair of linear equation in two variables? Any two linear equations in the same two variables are called a pair of linear equations in two variables. For example, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. These two equations represent two straight lines. But a very interesting thing is why the topic is pair of linear equations in two variables. Every linear equation represents a straight line, and our aim is to find out a solution or a point common to both the linear equations or the straight lines. The golden rule here is, in order to solve a linear equation in two variables, we need at least two linear equations in two variables to get possible solutions. So obviously, now the next question would be how a pair of linear equations in two variables can be described geometrically. As each linear equation represents a straight line, only three possible solutions can arise between two straight lines. Number one, the two lines will intersect at one point, as shown in the diagram. The second scenario would be the two lines will not intersect, that is, they are parallel, so they will never intersect. The third scenario is that the two lines will be coincident. Let's take examples of each. So, the first example is, I went to the store to buy pens and pencils. The number of pencils is 1/4 of the pens. The total that needs to be spent on is rupees 30. Find the number of pens and pencil bought. Both pen and pencil cost rupees 2 each. This has to be solved geometrically. So the solution is, to represent the equation graphically, two solutions are needed for each equation. Remember the golden rule? So say x is pencils and y is pens. For every one pencil, there are 4 pens. So we can plot it as, when x is equal to 0, obviously y is equal to 0. But if x is equal to 1, y, that is the number of pens, will be equal to 4. But we also know that if we just buy the pens and pencils all together without any counting, their total sum should be equal to 30. That is, 2x plus 2y is equal to 30. Now if we see that when x is equal to 0, that is, the number of pencils is 0, we still can buy 15 pens. But if we only buy the pencils, that is x, then y is equal to 0. That is, the number of pens will be 0. So the next plotting shows when x is equal to 0, y is equal to 15, and when x is equal to 15, y is equal to 0. Graphically, we see that the two lines y is equal to 4x and 2x plus 2y is equal to 30 intersect at 3, 12. This implies that in rupees 30, we can get 3 pencils and 12 pens. Let's take example 2. There are two linear equations in two variables, 3x plus 4y is equal to 12 and 6x plus 8y is equal to 24. find possible solutions. The solution is these pair of linear equations have infinitely many solutions as they overlap each other. If you see carefully, if we divide the second equation by 2, we get the first equation. A pair of linear equations in two variables that intersects on one point are called consistent pair of linear equations. A pair of linear equations in two variables that overlaps has infinitely many distinct common solutions. This is called a dependent pair of linear equations in two variables. The dependent pair of linear equations is also consistent. Let's take example 3. There are two linear equations given as 3x plus 4y is equal to 12 and 3x plus 4y is equal to 18. These two linear equations represent parallel straight lines. The value of LHS, that is 3x plus 4y, is the same but RHS is different. This is a clear indication that the linear equations point to parallel lines. A pair of linear equations in two variables that do not intersect are called inconsistent pair of linear equations. How to solve a pair of linear equations in two variables graphically? Graphical method of solution of a pair of linear equations is, in one of the previous examples, the point 3, 12 is common to both the straight lines, so there is one and only one solution for this pair of linear equations in two variables. a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 are two linear equations in two variables, x and y. Based on the ratios of a1 and a2, b1 and b2, and c1 and c2, the graphical representation can be understood very clearly. For this, we have created a simple table where we will be comparing the ratios of the pair of lines, that is a1 by a2, b1 by b2, c1 by c2, and also be marking as whether they are consistent or inconsistent, and the graphical representation, and then finally the algebraic representation. So if the first representation we see, a1 by a2 is not equal to b1 by b2. In this scenario, we have taken an example as 3x minus 4y plus 8 is equal to 0. Another linear pair in two variables is 7x plus 6y minus 9 is equal to 0. The ratio of a1 by a2 here, we see that is 3 by 7. And the ratio of b1 by b2 is minus 4 by 6. So we see that a1 by a2 is not equal to b1 by b2. So this pair of linear equations is consistent. The graphical representation would be intersecting lines and algebraic representation would be exactly one solution which is unique. Let's talk about the second scenario. a1 by a2 is equal to b1 by b2 is equal to c1 by c2. In this scenario, the example that we have taken is 5x plus 3y plus 12 is equal to 0 and 10x plus 6y plus 24 is equal to 0. Here we see that the ratio of a1 by a2 is equal to 5 by 10, b1 by b2 is 3 by 6 and c1 by c2 is 12 by 24, which all can be reduced as 1 by 2. So here we see that two linear equations in two variables are dependent but are consistent. The graphical representation would be coincident lines. The algebraic representation suggests that this can have infinitely many solutions. The third scenario is a1 by a2 is equal to b1 by b2 but is not equal to c1 by c2. Let's take an example where the two linear equations in two variables are 4x minus 2y plus 10 is equal to 0 and 2x minus y plus 9 is equal to 0. The ratio a1 by a2 is 4 by 2, b1 by b2 is 2 by 1, c1 by c2 is 10 by 9. We can clearly see that a1 by a2 is equal to b1 by b2, but that in turn is not equal to c1 by c2. So in this scenario, two linear equations in two variables are inconsistent. The graphical representation would be parallel lines, an algebraic representation, we can have no solutions for these two lines, as these two lines are parallel and they will never intersect. So let's take an example. Check graphically if the pair of equation 3x plus 2y equal to 6 and 3x minus 2y equal to 12 is consistent. If so, solve them graphically. Taking the ratios of a1 by a2 and b1 by b2, we see 3 by 3 is not equal to 2 by minus 2. So the equations are consistent. The lines representing these equations have a unique solution and are intersecting lines. Let's talk about the graphical approach. When x is equal to 0, the value of y becomes 3. When x is equal to 2, the value of y becomes 0. For the next equation, when x is equal to 0, the value of y becomes minus 6. And when the value of y is substituted as 0, we see that the value of x becomes 4. So plot the points A, that is 0, 3, B 2, 0, and P 0, minus 6 and Q 4, 0, and join the points to form line AB and PQ. It is observed that the lines intersect at 3, minus 3 by 2. So that forms a solution. It is time to look at various ways as to how to solve a pair of linear equations in two variables with algebraic method. But before that, a more relevant question is, why another method when we have a graphical method? This method has a more realistic significance as graphical method is not convenient in cases where the point representing the solution of the linear equations are non-integer coordinates like root 2, root 5 or 5 by 13, 2 by 19 or minus 1.33, 2.2, which are decimal coordinates. In algebraic method, we do not need to plot these, but value can be written simply. So it's much simpler. So finally, we arrive at the question, how to solve a pair of linear equations in two variables with algebraic method. There are several algebraic methods, namely substitution method, elimination method, cross multiplication method. So the next question obviously is, what is substitution method? The substitution method is an algebraic method to solve a pair of linear equations. As the name suggests, the value of one variable from one equation is substituted in the other equation. Let's see this with example. How to solve using substitution method? Step 1. Find the value of one variable in terms of the other variable. Example, y in terms of x. This is done as per convenience. Step 2. Substitute this value of the variable in the other equation and reduce it to an equation in one variable. Just to check as a step 2a would be, in case we get a statement equation with no variables, this implies that the pair of linear equations has infinitely many solutions. But generally, if we have consistent solutions, then we substitute the value derived in step 2 of the variable to obtain the value of the other variable. Let's look at some examples. Solve the following pair of linear equations by substitution method. 5x plus 3y is equal to 40 and x plus 2y is equal to 15. The solution is, step 1. Pick any equation and write one variable in terms of the other. Considering x plus 2y is equal to 15 can be written as x is equal to 15 minus 2y. Step 2. Substitute the value of x into the other equation. So we substitute the value of x as 15 minus 2y in the equation. So we get 5 multiplied by 15 minus 2y as in a bracket as a whole plus 3y is equal to 40, which in turn gives 75 minus 10y plus 3y is equal to 40, which finally implies 7y is equal to 35 and y is equal to 5. Now substituting the value of y, we get x is equal to 15 minus 10, which is equal to 5. Therefore, the solution is x is equal to 5 and y is equal to 5. The verification can be done by substituting the values of x is equal to 5 and y is equal to 5, which satisfies both the equations. Let's take another example to see what we have learned. Solve the following pair of linear equations by substitution method. 3x plus 4y is equal to 12 and 6x plus 8y is equal to 24. The solution is, let's step 1. Pick any equation and write one variable in terms of the other variable, as we did for the previous example. That is, x is equal to 12 minus 4y in parenthesis. Finally, the complete thing is divided by 3. Step 2. Substitute the value of x in the other equation. So that becomes 6 multiplied by 12 minus 4y in brackets and divided by 3 as a whole, plus 8y is equal to 24. As 6 is a multiple of 3, we can simplify it, and finally we have 24 minus 8y plus 8y is equal to 24. Here we see that we are suggesting 24 is equal to 24. As we see the variables get cancelled, this implies that the pair of linear equations has infinitely many solutions. So this becomes a dependent pair. Now, what is an elimination method? Let's see with an example. The elimination method is the process of eliminating one of the variables in the system of linear equations using the basic arithmetic operations, that is, addition, subtraction, multiplication, and division, or their combination. So how to solve using elimination method? Step 1. Multiply both equations by a suitable non-zero constant to make the coefficients of one variable, either x or y, numerically equal. Pair of linear equations, the two variables, so we can have 4x minus 5y is equal to 7, which can be marked as equation 1, and 2x plus 4y is equal to 10 is the equation 2. Multiply equation 2 with 2 will obviously equal the coefficients of x variables to 4. So 2 multiplied by 2x plus 4y is equal to 8, implies 4x plus 8y is equal to 20. Step 2. Add or subtract one equation from the other so that the variable that was equated by multiplication gets eliminated. So finally we are subtracting 3 from 1, which gives us 4x plus 8y minus 4x plus 5y is equal to 20 minus 7, which implies that 13y is equal to 13. So after step 2, if both the variables are eliminated and the remaining constants are actually equal, then the pair of linear equations has infinitely many solutions. This is not the case in the example we are working on, but this is a good point to remember. After step 2, if both variables are eliminated and the remaining constants are not equal, then the pair of linear equations have no solutions. That is, it is inconsistent. Steps 2a and 2b are the considerations that we have to show while making our logical ability more perfect. Step 3. After step 2, only one variable is eliminated. Then solve the equation in one variable, x or y, to obtain its value. So here we get 13y is equal to 13, which implies that y is equal to 1. And finally, we have step 4, where we substitute the calculated value of one variable in the equation and determine the value of the other variable. So if we substitute the value of y is equal to 1, we get 4x minus 5 into 1 is equal to 7, which implies that 4x is equal to 7 plus 5, which implies that 4x is equal to 12 and x is equal to 3. So x is equal to 3 and y is equal to 1 is the solution of the pair 4x minus 5y is equal to 7 and 2x plus 4y is equal to 10. Let's take another example to really validate what we have learned further. Use elimination method to find all possible solutions of the following pair of linear equations. 3x minus 5y minus 4 is equal to 0 and 9x is equal to 2y plus 7. The solution is step 0. Let's simplify the problem. So we have 3x minus 5y minus 4 is equal to 0. as the first equation, and we have 9x minus 2y minus 7 is equal to 0 is equating all equations to 0. This is called the simplification strategy. We have just marked this as step 0 and given this as an example so that you remember that this is also has to be done. An equation has to be equated to 0. Step 1, taking x as a variable to equate, multiply equation 1 with 3 to have the digit 9 as the coefficient of x. So 3 multiplied by 3x minus 5y minus 4 is equal to 0, which gives 9x minus 15y minus 12 is equal to 0 as the third equation. Step 2, subtracting equation 3 from 1, we get 9x minus 2y minus 7 minus 9x plus 15y plus 12 is equal to 0. And here finally we get 13y plus 5 is equal to 0. Solving for y, we get y is equal to minus 5 divided by 13. Step 4 is solving for x. So we have 3x minus 5 into minus 5 by 13 minus 4 is equal to 0, which implies that 39x plus 25 minus 52 is equal to 0, which in turn implies that x is equal to 27 by 39, which can further be simplified as 9 by 13. Let's take another example for elimination method. Use elimination method to find all possible solutions of the following pair of linear equations: 3x minus 5y minus 4 is equal to 0 and 9x is equal to 15y plus 12. The solution is, again, step 0, 3x minus 5y minus 4 is equal to 0, as the equation is equated to 0 is equation 1, but we are simplifying the other equation, and finally we get 9x minus 15y minus 12 is equal to 0 as a second equation. Here we are equating all equalities to 0. Step 1, taking x as the variable to equate, multiply 1 with 3 to have 9 as the coefficient of x. So 3 multiplied by 3x minus 5y minus 4 is equal to 0, which ends up giving us 9x minus 15y minus 12 is equal to 0 as the equation 3. Subtracting equation 3 from 1, we get 9x minus 15y minus 12 minus 9x plus 15y plus 12 is equal to 0, which implies that 0 is equal to 0. Both variables are eliminated and 0 is equal to 0 implies that there are infinitely many solutions. Another example is use elimination method to find all possible solutions of the following pair of linear equations: 3x minus 5y minus 4 is equal to 0 and 9x is equal to 15y plus 7. So here again the step 0 is 3x minus 5y minus 4 is equal to 0 as the first equation, and if we again solve it, 9x minus 15y minus 7 is equal to 0 is again the equation that is formed after equations have been equated to 0. Step 1 is taking x as the variable to equate, multiply 1 with 3 to have 9 as the coefficient of x, which implies that 9x minus 15y minus 12 is equal to 0. Subtracting equation 3 from 1, we get 9x minus 15y minus 7 minus 9x plus 15y plus 12 is equal to 0, which implies that 5 is equal to 0, which is certainly not possible. Here we start with step 2b, where both variables are eliminated and 5 is not equal to 0. This implies there are no solutions. Let's start with the last algebraic method to solve a pair of linear equations in two variables, and that method is called cross multiplication method. So what is cross multiplication method? Cross multiplication method is an algebraic method to solve a pair of linear equations in two variables. It is derived from the elimination method, but is very handy as it has a clear picture to it. Pair of linear equations in two variables can be depicted as a1x plus b1y plus c1 is equal to 0. Let's mark this as equation 1. And then we have a2x plus b2y plus C2 is equal to 0. And we'll mark this as equation 2. So for the step 1, we will multiply 1 with B2 and multiply equation 2 with B1. So we have B2 multiplied by, in parenthesis, A1x plus B1y plus C1 is equal to 0, which will be marked as the third equation. And then we have B1 multiplied by A2x plus B2y plus C2 is equal to 0, which will be marked as the equation 4. Now, as part of step 2, we subtract equation 3 from 4. A2 B1x plus B1 B2y plus B1 C2 minus A1 B2x minus B2 B1y minus B2 C1 is equal to 0, which implies that A2 B1 minus A1 B2, this entirely taking it common, multiplied by x plus B1 B2 minus B2 B1, which is actually the same thing and it cancels out, multiplied by y plus B1 C2 minus B2 C1 is equal to 0, which implies that x is equal to B2 C1 minus B1 C2 divided by B1 A2 minus B2 A1, provided A2 B1 minus A1 B2 is not equal to 0. Now step 3, we see that substituting this value of x in equation 1 or 2, we see that the value of y is equal to A1 C2 minus A2 C1 divided by A2 B1 minus A1 B2. Now here, two cases are possible. Case 1, A2 B1 minus A1 B2 is not equal to 0. In this case, A1 by A2 is not equal to B1 by B2. So finally, the pair of linear equation has a unique solution in this scenario. The case 2 can be a possibility where A1 B2 minus A2 B1 is equal to 0. In this case, A1 by A2 is equal to B1 by B2, and let's assume that is equal to k. That means A1 is equal to k times of A2 and B1 is equal to k times of B2. Substituting values, the equations can only be satisfied if C1 is k times of C2. So applying basic maths, we get if A1 by A2 is equal to B1 by B2 is equal to C1 by C2, which is equal to k, then there are infinitely many solutions of the pair of linear equations in two variables. If C1 is not equal to k into C2 or k times C2, then the solution of equation 1 will not satisfy equation 2 and vice versa. So there are no solutions. So algebraically also, we arrive at the same summary. When A1 by A2 is not equal to B1 by B2, we get a unique solution. The second case is when A1 by A2 is equal to B1 by B2 is equal to C1 by C2, there are infinitely many solutions. And the third case is when A1 by A2 is equal to B1 by B2, but that is not equal to C1 by C2, there is no solution. The equations can be written as x divided by B1 C2 minus B2 C1 is equal to y divided by C1 A2 minus A1 C2 is equal to 1 divided by A1 B2 minus A2 B1. And when we depict it, we just write it in the format x, y, and 1, and then write B1, C1, A1, and again B1. Again, we write B2, C2, A2, and B2. This diagram gives us the real feel why this method is called the cross multiplication method. Now the next logical question would be how to solve using cross multiplication method. Step 1, write the equations in the form a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Step 2 would be using the cross multiplication diagram, write the equation. The trick is to flow from top to bottom. So finally, in step 3, we find the values of x and y, provided a1b2 minus b1a2 is not equal to 0. Let's take an example. Solve the following equations by the cross multiplication method. The equations are 2x plus 3y is equal to 22 and 3x plus 4y is equal to 32. So the solution is step 1. Remember, equations in the regular form would be 2x plus 3y minus 22 is equal to 0 and 3x plus 4y minus 32 is equal to 0. Now we can refer the cross multiplication method diagram, and using the diagram we see that x divided by minus 8 is equal to y divided by minus 2 is equal to 1 divided by minus 1, which implies that x by 8 is equal to y by 2 is equal to 1. Solving that, x is equal to 8, y is equal to 2 is the solution. See how quick it was. Let's take another example. For what value of k will the following pair of linear equations have no solution? The equations are 3x plus y is equal to 1 and 2k minus 1 multiplied by x plus k minus 1 multiplied by y is equal to 2k plus 1. The solution goes as part of step 1, we get equation in the regular form. We get 3x plus y minus 1 is equal to 0 and 2k minus 1 multiplied by x plus k minus 1 multiplied by y minus 2k plus 1 is equal to 0. As is given in the question that the pair of linear equations have no solution. So in step 2, a1 by a2 is equal to b1 by b2, which in turn means a1 by a2, which is equal to 3 divided by 2k minus 1, b1 by b2 is equal to 1 divided by k minus 1, and c1 by c2 is equal to 1 divided by 2k plus 1. For no solution, a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. So we have 3 divided by 2k minus 1 is equal to 1 divided by k minus 1, which implies that 3k minus 3 is equal to 2k minus 1. And finally, as part of step 3, we have k is equal to 2. Therefore, for k is equal to 2, the given pair of linear equations will have no solution. We have learned a simple concept of solving a pair of linear equations in two variables, both graphically and algebraically. But sometimes equations do not look as if they are a pair of linear equations in two variables. For those interactions, we have the age-old process of simplification or reducing the equation to form a pair of linear equations. So, how to reduce equations to form a pair of linear equations in two variables? A nonlinear equation can be reduced into linear form by making suitable substitutions. For example, let's take 3 by x plus 2 by y is equal to 8 and 4 by x plus 5 by y is equal to 13. By substitution, 1 by x is equal to p and 1 by y is equal to q, we get 3p plus 2q is equal to 8, which forms our equation 1, and 4p plus 5q is equal to 13, which forms our equation 2. Interesting that a simple substitution converted the equations to a pair of linear equations in two variables, and now the equations can be solved as per what we have learned earlier. Now let's multiply equation 1 with 4 and equation 2 with 3. We get 12p plus 8q is equal to 32, which forms our equation 3, and we get 12p plus 15q is equal to 39, which forms our equation 4. Subtracting equation 3 from 4, we get 12p plus 15q minus 12p minus 8q is equal to 39 minus 32, which in turn gives us 7q is equal to 7, which implies that q is equal to 1, and finally when we substitute the value of q, we get p is equal to 2. Substituting back is a very important part. See, remember we had taken 1 by x is equal to p. Finally, we have to bring it to the values of x and y and not q and p. So, substituting it back to x and y, we get x is equal to 1 by 2 and y is equal to 1 by 1, which is equal to 1. This is exciting. So all we did was substitute so that variable expression in denominator are assumed to be another variable and solved like a regular equation. Let's look at an example. Solve the equation 10 divided by x plus y plus 2 divided by x minus y is equal to 4 and 15 divided by x plus y minus 5 divided by x minus y is equal to minus 2. The solution would start with a substitution, obviously, where we substitute 1 divided by x plus y is equal to a and 1 divided by x minus y is equal to b. So the equation becomes 10a plus 2b is equal to 4, which forms our equation 1, and 15a minus 5b is equal to minus 2, which forms our equation 2. This always fascinates me how a simple substitution converts a complex equation into a linear equation. So now let's continue forward by multiplying equation 1 with 5 and equation 2 with 2. So finally we have the two equations as 50a plus 10b is equal to 20, which forms our equation 3, and 30a minus 10b is equal to minus 4, which forms our equation 4. As we can see, we will be adding the equations 3 and 4 here. So we get 80a is equal to 16, which implies that a is equal to 1 by 5 and b is equal to 1, which can be verified from the equation 2 also. Now reducing to the original variables, we have 1 by x plus y is equal to 1 by 5 and 1 upon x minus y is equal to 1, which implies that x plus y is equal to 5, which forms our equation 5, and x minus y is equal to 1, which can form our equation 6. Now again, we have two equations in two variables, and now it is pretty simple to solve the equations. We just add equation 5 and 6. We get 2x is equal to 6, which implies that x is equal to 3. And finally, when we substitute the value of x in the equation, we get y is equal to 2, which obviously can be verified with equation 6. The degree of the variables of the equation in such scenarios may not be 1 also. That is also a possibility. So let's take an example of that nature. Solve the equation 2 divided by root x plus 3 divided by root y is equal to 2 and 4 divided by root x minus 9 divided by root y is equal to minus 1. So again, we start the solution with the substitution. 1 divided by root x is equal to a and 1 divided by root y is equal to b. Now the equation again becomes pretty simple. 2a plus 3b is equal to 2, which forms our equation 1, and 4a minus 9b is equal to minus 1, which forms our equation 2. Multiplying equation 1 with 3 and equation 2 with 1 would give us 6a plus 9b is equal to 6, which forms our equation 3, and 4a minus 9b is equal to minus 1, which forms our equation 4. Adding 3 and 4 so that the 9b cancel each other, we get 10a is equal to 5, which implies that a is equal to 1 by 2, and substituting the value of a in the equation 3 or 4, we get b is equal to 1 by 3. Again, reducing back to the original variables, we have 1 divided by root x is equal to 1 by 2 and 1 divided by root y is equal to 1 by 3, which implies that root of x is equal to 2 and root of y is equal to 3. And finally, squaring both sides, we get x is equal to 4 and y is equal to 9 as the answer. Pair of linear equations can also be created by word problems. Let's take an example. The ages of two friends, Ani and Biju, differ by 3 years. Ani's father, Dharam, is twice as old as Ani and Biju is twice old as his sister Kathy. The ages of Kathy and Dharam differ by 30 years. Find the ages of Ani and Biju. Let's start with the solution. It's time for a pointer here. When we see a word problem, then converting the word problem into a simple equation is an independent learning. Based on the former equation, we try to judge what kind of equation or equations are formed. If the equations formed are a pair of linear equations in two variables, then we solve it this way. If the equations are quadratic, then we may apply other concepts that we'll be learning in other courses. So let's convert the word problem to equations. Let Ani's age be x and Biju's age be y. Difference in their ages is 3, which implies that x minus y is equal to 3. This forms our first equation. Now, Dharam, who is Ani's father, is twice Ani's age. So, Dharam's age would be 2 times x. Kathy, who is Biju's sister, her age is half of Biju. So, her age is equal to y divided by 2. Now, Dharam's age minus Kathy's age is equal to 30 years as given in the question, which implies that 2x minus y by 2 is equal to 30. This forms our second equation. Now, we see that equation 1 and 2, we have two equations in two variables that can be solved by the methods that we discussed earlier. So, multiplying equation 1 by 2 and equation 2 by 1, we get 2x minus 2y is equal to 6, which forms our equation 3, and 2x minus y by 2 is equal to 30, which forms our equation 4. Subtracting equation 3 from 4, we have 2x minus y by 2 minus 2x plus 2y is equal to 30 minus 6, which implies that 3y divided by 2 is equal to 24, which finally implies y is equal to 16. And by substituting the value of y in the equations 1 or 2, we get x is equal to 19, which implies that Ani's age is 19 and Biju's age is 16. This brings us to the end of the course. This course outlines a very important part of your development called pattern recognition. Pattern is that if we see a pair of linear equations in two variables, then how we can solve the same with the help of tools we learnt in this course. That is substitution, elimination, and cross multiplication, or graphically also. It is time for some more challenges. Hope you liked our presentation. Happy learning!